Oh, I can do share screen. Welcome, everybody. Why don't you go ahead and sign in to your YouTube on the Patristic Faith so that you can interact with the children online.
I love interacting with children. Wait.
More interactive.
Pause. Hold up.
Hold a minute.
That's the case.
This is a more interactive course.
I'm not a child. I'm above 18.
Oh, that's wild, actually.
Everybody give a shout out. We are going to do philosophy of mind. And if I do share.
I'm so behind. Hello, chat. Welcome.
Philosophy of time, pre-college lecture. Oh, it still says upcoming.
It still says upcoming?
Nope, now we're good.
No.
Daniel Tan asks, is this actually live? How do I respond to
Just say yes, Daniel.
All right, tell me if you can see. Yeah, you can see the time. Time to get to work.
Okay.
All right, look at all these books I got.
Why?
Because we're going to have a smorgasbord of different faith style of the greatest thinkers in Western civilization on the topic of time. Now, some of these are going to be philosophers. Some of them are going to be scientists. And one thing that I want you to pay attention to as we're going through the philosophy of time is how does science think about time and how do the philosophers? What are some of the similarities? What are some of the differences? Has anybody stopped to think about, deeply the topic of time? Did you get yourself more confused? There's probably several things like that that are paradoxical in that, well, wait a minute. Time's surrounded all around. My grammar's tensed.
Well.
Past, present, future. I operate my whole day within time. It's so close. And then you start to introspect into or make an analysis of what time is, and you get yourself really confused. There's probably a lot of things like that. Maybe the self or personhood is like that. What do I know more than myself? And then you explore and you get yourself super confused. Theology is like that. Of course I believe this. Then you ask to explain it, and then you sound like a heretic because you don't know what you're talking about. So time is one of those things. It's not pre-recorded chase. I'm live. How could it be pre-recorded when I'm speaking to you, Chase, right now?
Wait, who's it? Where's Chase?
He's trolling me. Now I'm getting all mixed up in my philosophy of time. If it's pre-recorded, oh, I built a time machine into the future where I can actually be pretending that I'm live, but I'm actually in the past, something like that. So what we're going to learn in this lecture is how to build time machines. So we can confuse the Chase Haggards in the world.
Yeah, Chase.
All right. He's in the past. Exactly, Chase. He nailed it. I'm caught. Okay, I always like to begin this lecture with St. Augustine. St. Augustine, when I was your age, was one of my favorite books was The Confessions. Anybody read The Confessions? It's kind of like an autobiography from thug to saint. Living the thug life to living the saintly life. But it's very philosophical too. And so, as he's going through these different kind of events in his life, he kind of pauses and introspects and thinks about these philosophical topics. One of which is in the Confessions, book 11, is kind of a pause and thinking about the nature of time. Now, one of the funny parts in the book is, has anybody ever thought about if God created time, what was God doing before he created time? Well, that's to ask the question, what was God doing in the time before he created time? Do you see the weirdness of that question? What was God doing in the time before he created time? And there's a very, very simple answer to this. Anybody want to know?
Time does not affect God. He is outside of time, space, and matter.
Did you just, is that ChatGPT?
No, I saw this video of this guy and he's talking about it.
Well, we learned philosophy mind. We don't know if it's a real God. Problem in other minds, it's ChatGPT. What was God doing in the time before he created time? Very simple answer. He was creating a special place in hell for people who ask questions like this. Okay, and I am out of here. But it is weird. I mean, it just shows the complexities of, can I talk about a time before time? Well, I better figure out what time is. And so we turn to St. Augustine's Confessions, which, by the way, like I said, was my favorite book when I was, maybe it was a little bit older than you. But I was I think it was a freshman or sophomore when I read it. In fact, do you know that I made my wedding cake into St. Augustine's Confessions? That's how much I love. If that's proof of anything, it's like, well, that guy, he obviously, he put that book even before his marriage by making his wedding cake a book of St. Augustine's Confessions. No, what happened is my mother-in-law asked me at the time what was my favorite book, and I told her St. Augustine's Confessions, thinking that I was going to get like this awesome wedding present of a rare edition. Instead, my wife and my mother-in-law went to one of those fancy cake places that can make cakes look like anything, and they made it our two favorite books. My wife's was Jane Austen's Emma, and mine was St. Augustine's Confessions. Nobody believed me that it was cake because it looked so well done, binding and the leather and stuff, until we cut down into it. Anyways, that's my St. Augustine cake story for you. But let's go to book 10, in which he talks about time. And we open up the lecture with this famous quote. That really reveals the paradoxical nature of time. So close, but so far away, you see. So close, so far away. What is time? Who can explain it easily and briefly so as to offer, who can grasp this even in cognition so as to offer a verbal explanation? That's what we want, right? Yet, what do we mention in speaking more familiarly and knowing than time? We certainly understand it when we talk about it. We're talking about it. You know what I'm talking about? Time. Nobody's like, what's that? I've never heard of that. Whole days organized in it. Our grammar is tensed within the language of time. You should know it better than anything. In fact, We even understand it when we hear another person speak about it. So then what is time? And here's the funny kind of part that summarizes the paradox. Well, if no one asks me, I know. But if I want to explain to someone who asks me, I do not know. Confessions, book 11, chapter 14. Isn't that nice? Kind of a nice way to start off. The paradoxical nature of time. So close, yet so far away. Who's the lecturer? St. Augustine's a lecturer right now. Okay. Any questions about that so far? It's going to be difficult. Guess how long I've been thinking about time?
For a long time.
23 years. I haven't made too much advancement. Okay? Some advancements, but it's been slow and difficult. Why? Who can explain this? It's so difficult. So I don't expect in these 3 lectures on time that you're going to solve it. I got it. If it's taken me 23 years to just get to this point. So what we're going to do, we're going to have a buffet style. How many people like buffet style? All you can eat, philosophers and scientists, for what? $13.99. We're going to sample some of the thinkers, some of the greatest scientists and some of the greatest philosophers, some of the greatest theologians, and just get a flavor for it to leave you thinking for the next 23 years on what time is. Okay? Now, I started first thinking about this when I took, before I even went to Thomas Aquinas College for undergraduate, I went to community college to take some math and science courses. I was going to be a physicist. So obviously in physics, you're thinking about time, and then I was also taking some philosophy courses and thinking about time as well. And it all starts there. And in fact, in history itself, it starts with physics. Who is the founder of physics? Who can name him? Wrote a book called The Physics. Anybody in the chat? All right, we're going to compete with the people in class, with the people in the chat. Oh, winner, chicken dinner. Who?
Oh,
Oh, Dusseldorf. That's a pretty close tie. Me. Aristotle.
Aristotle.
Neil Tyson. Okay, so in the physics, and each book is dedicated to something different. Well, by the time we get to book 4, chapters 10 to 14, now a lot of the physics is about motion. But in this book, chapters 10 through 14, he brings up time. Okay? So what we're doing here is we're categorizing. We have different categories. What's listed right now? Motion and time. And by the way, part of what could be elusive about this too is that we complicate things. I brought up, and you got to try this, how many people have asked little children deep philosophical questions?
no one has children.
Really? Oh, that's great.
How old are you?
I don't know, like 6, 7, 8.
I've heard some.
They have better answers.
They sometimes they're really dumb, and you're like, sometimes they're better. Yeah, you don't speak unless you've been spoken to, son. Now, I think one of the reasons for that is that, well, as we began this whole course with Aristotle, all men, this is from the Metaphysics, by nature desire to know. It's in your nature to be a knower, and that's why you desire it. In other words, it's in your nature to be a thinker, a philosopher. Right? If we associate philosophy with thinking and attempting to know. And that's why I think children are naturally demonstrate being philosophers. Why? What do philosophers do? They ask a bunch of questions. What's that? Why come that? How do you know that?
Why come?
And then what do? Unfortunately, we train to stop asking questions and being philosophers. It's really sad. Sometimes we get educated the wrong way, or maybe life just becomes more complicated and it becomes difficult to see things. Sometimes children can just see reality. And if one thing that philosophy is attempting to do is to discover and see reality. So you can demonstrate this sometimes by asking children philosophical questions, which is, I always bring this story up again in this lecture. My nephew, when he was about 7 years old, he is now 22. Any 22-year-olds here? Okay, we got our sample. I asked him, what is time? Deep philosophical question. And I started going through categories. And we're going to do this when Immanuel Kant's going to do this too. But right now, we're looking at Aristotle, just the category of motion. We can think about, well, what is time? Is it a substance? Now, how do you explain substance to a 7-year-old? Pick up your cup right now. Hold it up. That's a substance right there. It's glowing. What is that? It is, let me guess. It is a passion fruit tea. No, it's not. It's totally off. What is it?
This is complicated. This is a strawberry refresher, but it's got peach and has dried fruits. It's just a mix of juice, basically.
But it's still a substance, nevertheless.
Nevertheless.
And obviously that must be what time is, right? Something you can pour into a glass and drink. Right or wrong? Wrong, says the 7-year-old as well. Wait a minute, what's that on the back of the class right there? That's a clock. That's obviously time, right? That is time.
That tells time.
That tells time. That's what he says as well. Correct. Just like if I brought up a thermometer and was like, look at this heat I have in my hand. Would you think I was on drugs? That's not heat, it tells heat. Okay, I'm going through different categories. Correct. So I asked my nephew at 7 years old, what is time? Guess what he tells me? You see, time is, in case you didn't know, reality.
Time is money.
Time is the thug life. You see. Now, I had to laugh because I thought that was a profoundly deep statement. Time is reality. Why? Because it took the German philosopher of the 20th century, Martin Heidegger, his whole life, and magnum opus, one of the smartest thinkers, to write a book called Sein und Zeit, which in German is Being and Time, to come to a conclusion that being a reality is time. And here the 7-year-old was able to answer it like that. So again, so close, but then so far away when we try to explain this. We'll revisit this, but I just wanted to tell you that story. Okay, so Aristotle realizes it's connected to motion. Now, an important point, though, he says they're not the same thing. Not every instance of motion is time, and for something to be the same, every instance of on the left-hand side would be the right-hand side and vice versa. Correct? I want to show you an example. Every instance of H2O is what? Water. Every instance of water is H2O. Why? Because they're equal. These things are not equal. That's what Aristotle says. Although related to motion, time is not motion. In other words, motion and time are not the same thing. But he doesn't just leave us there, right? He says, but it's not independent. Oh, so we have dependence. These are going to be called my dependence arrows. Meaning, there's only one arrow. Which one's dependent on what? What does he say? You can have, so there is no time without motion. That tells you which one's dependent. Time is dependent on motion. If there's time, there's motion, but not the opposite. Does everybody follow me on that? That means time rides on the back of motion. But motion doesn't need time to take a ride. Does that follow? Does everybody get that? Okay, I'm going to bring up aporia, which in Greek means a puzzle, a problem. Okay, well, how do you measure, how do we measure the unit, 1 unit in 24 hours? One rotation of the Earth in which you will see the sun rising in the east. Again, you're on drugs. So you see it right. Whoa. Rising in the east, setting in the west. In 1 year, one rotation around the sun. That's motion, right? Now, what's bizarre about this statement? There can be motion without time. You're telling me the Earth can make one rotation around its axis or one rotation around the sun in no time? Does that seem puzzling to you? But if it would have to follow, if time and motion are not the same thing, I use motion to tell time. Must be something, that means things can move without there being time. I'm just using the motion of time. Okay. Everybody follow me. Now, all of this would mean motion are objects in the world, right? So you get the notion of being objective. Motion is objective. Why? Because you have space and you have objects moving through them. But if motion, time is not motion, time depends on motion. We use motion to give us what? A unit of time or something. To look at the clock up there, it's moving. Then this might lend to the consideration, is time psychological? This is physical versus psychological? Might it suggest that? Why? Because you can have objects in the physical world moving and no time. So where does time come in? You're using it. Who's you? The person, the psyche, using it. Now, let's go through some examples that might lend to the proposition that time is something psychological. How many people have heard the phrase, time flies when you're having fun? What the heck does that mean? Oh, in case you can't see can't even see the red. We need a marker in which you guys can see. Kind of see it. What does time flies when you're having fun mean?
It goes by really fast.
It goes by really fast. Let's just take the semester. In the beginning of this semester, time went by slow or fast? Slow. It's going by what right now? Fast. Oh man, this marker is great. Time.
I still don't think I can see that.
I think if you go
Like if you
What if I wrote backwards?
on that side.
I will write on that side eventually.
come on, guys, didn't know.
Everybody seen those National Geographic things where like the guy's like trying to fly, like it's like the life of a fly, your average flight, and it's like they have the human being trying to swat the fly, okay, and you can't get it, and then it goes into the fly's perspective, and then the fly's like, and like what does the fly see? It's like super slow, right? Well, the motion's the same objectively, correct? What's going on? Perhaps something psychologically. The way that you experience time might be linked, might be a psychological phenomenon. How well is your time when you're sleeping?
Goes by
Is it pretty accurate? Why? You ever wondered?
You don't really have a concept of what you're sleeping.
What's that?
You don't really have a concept of what you're sleeping.
Why? Why don't I have a concept of it's going by too fast? Like, I have dreams where it seems like days, years.
When you wake up, it doesn't feel like it's been
Yeah,
that long.
or vice versa. Because I'm not aware of something external. If I'm using I'm using objective motion to tell time. Aristotle has sensation is the objective world doing what to you? Moving and pressing in on your five senses, which are what? Touch, taste, sight, let's do sound. And smell. It's the world moving in. So what happens, you're not, and if this is where your awareness is, your conscious awareness uses your senses. When you fall asleep, you're no longer aware of what's moving around you. So your sense of time in your mind is off. We can actually do a physical experiment with a sense deprivation tank. How many people have heard of a sense deprivation tank? How many people heard of Joe Rogan? More hands. Joe Rogan is selling us a sense deprivation tank. And what is a sense deprivation tank? Well, let's just look. Comes in a kit like this. Okay, so I can build this, right? So I can put water in it. I'm going to make the water a certain level of salient water, a certain level of salt. Why? What's that? So I can float. Stranger Things uses it. Even farther back, Altered States is another. That one's from the 80s. Okay, now why would I want to float?
Shits and gigs.
One way to look at it.
You know. Well, how do I know where my body ends? Suppose I was blind. So I've canceled out my sight. How would you know where your body ends? Yeah. Is that you? Or is it me? No, this is, all right. So the touch of something else pushing back tells me there's something else there. The blind people would do this, okay? So you're obviously in this thing and you can't see. Because you're going to close the door. So you would know if you were touching, right, something. Oh, here's where my body ends and the other object begins. But now you're floating. So you can't actually touch the container. But you know that where your body still is because the temperature difference. So bring the temperature up. Here it says 93.5. It's close enough to your body temperature. Then now you can't. You're floating. It feels like you're floating in space. The door is closed. You can't what? You can't touch anything. You can't taste anything. You can't see anything. There's no noise. And hopefully there's no smells in there.
What if your head hits the wall, like you just like float into it?
Then you kind of come back to something, like you're kind of grounded. Okay, what do you think the first thing that happens in one of these things when you do that?
Okay.
By the way, how many nursing students in here? All right, nursing students, you know this. What is anesthesiology?
It's like eliminating the body.
Yes. Now, why would I want to do that?
So you don't
Because if I'm doing an operation, I don't want you to, right, in the objective world, what I'm going to do, surgery, I don't want you to be aware of that. Or move. So I knock you out. I anesthetize you chemically. Speaking of the fly from the movie. Hey, buddy.
I don't even know if
It's not a fly.
and they always attack.
They always.
It's a military weaponized drone. Have you seen them now? They've come out.
What's it have against Noah?
There's like somebody in Alstrom, like on a computer, like zzz, with a little fly spying on us. That's right. You know what I'm talking about.
Are
Okay,
you talking about like the little journals?
I've been able through the sense deprivation tank to anesthetize you
Huh, big baby.
Well, technically, you still.
while you're still awake. Oh,
To some extent, you still have all of those things.
you still have them.
Because you're conscious.
You're still conscious but there's nothing plugging into touch, taste, sight, sound, smell. You've done basically the same thing without knocking yourself out, which is weird.
Whatever that dreaming is called.
What's that?
Whatever that dreaming is called.
Lucid
Lucid
dreaming.
dreaming?
There it is.
Next lecture, I will tell you how to do lucid dreaming. I know how to do it. So what happens?
Shut up.
You lose track of time. Makes sense, right? All of this suggests that time might be something psychological. People are in here and they actually go, I've been in here for an hour. And it's like, maybe it's been a couple of minutes. Psychedelics will produce the same thing. Oh man, I've been like living out in the woods for like 3 years. It's like, it's been 5 seconds, dude. Or vice versa.
Yeah, 5 seconds really felt like 3 years.
It was like it was 8 hours and they're like, thought it was a second. It's all messed up. Why? You're messing with your psyche and the stuff that you're not able to grasp the objective motion in the world, and so your time goes off. All right. That makes sense to me. Does it make sense to you?
Have you ever been in?
I haven't. When I was in grad school, though, I found a bunch. I actually gave them my, and I brought them. Let's see. I handed them out when I was teaching in Ireland, but they had like a sense deprivation. And then also when I was in California, I found like somebody had like a free float, and we never got to do it. It'd be great. We don't have one. We do? Where? In the science lab.
It's over by the hospital. I know who runs it.
And the guy
They have, like,
in the
free
military
floats.
base, in the government,
Yeah.
in a secret. I'm like, I don't think. Hey, a free floating at the. Well,
It is
all
run
right.
by a lieutenant. This is kind of funny.
Oh, funny. How did I know that? Because I'm inside his head. We're actually in
Oh.
a sense deprivation tank right now, and this isn't real.
It's a
And
dream.
neither is this in the chat.
So one of the chats said that they've done
Yeah,
Who are these people?
that's a great question. Who are these people? How many people do we have in the?
42.
All right, let's get those numbers up. Lived in a house with a sense deprivation tank, float tank, did multiple times a week, lost his mind.
Oh my god. So bored.
You don't want to
You ought to have sign a waiver that your professor is not responsible if you lose your mind or show up to work late because you thought you were only in a sense deprivation tank for a couple minutes and it had been 3 days.
You really think they'd leave you in there for 3 days?
Oh yeah, they will. They will. That's exactly what they would do.
Would you do like
Proven.
like when you fall asleep?
I don't think it's.
Well, that's why most
I don't think it's.
What if I turn around while I'm sleeping?
Just drown.
I don't think you sleep is the thing.
But if you're in there for 3 days, maybe.
That's an interesting question. Can you fall asleep?
Yes.
Well, don't drink or like if you're drunk, maybe. Like if you roll over, I could see that. They probably have things on there like no drink or drug use. And
This stuff is like therapy.
for therapy, you like
Why wouldn't
relax.
you be able to sleep? Well, also if it's like self-posed, then like you have to like how would you?
Yeah, I don't think it's deep enough to. Yeah, we'll never know.
These are self-love.
There, thank you. All right, let's go back in history, not too far. Let's rewind 23 years ago, in which I was not a clergy and I was not a professor. I was your age. And I'm taking math and science courses because I'm going to be a physicist. That's what I determined. I was also taking philosophy courses, again, where I started thinking about time. And one of the things, if you're thinking about science all the time, and then the issue of time comes up, you're probably going to pull out a science or math formula, correct? Now, we won't get too complicated. The very first one that you're going to think about is one that you see in your car with the speedometer. And what's a speedometer? When you're driving,
It measures speed.
it says 55 miles per hour. Okay, and what is that? That's velocity, correct? Speed is
Power.
velocity. Speed kills. What's the formula for velocity? V equals miles divided by per
Hour.
hour time. Okay. Everybody see that in the chat? So I just started there. I just thought, cool, I got a formula. Formulas tell you what things are. Okay, now I know what velocity is. I just need to figure out what time is. I need to have time. What is time as we begin the lecture? Well, what do? I need to get my t variable over here. What you do to one side, you do to the other, correct? These cancel?
Yeah.
Okay, so now I have time equals, I have time multiplied by velocity equals distance. That's not what I want. So I do one more move. I cancel out my velocity, and I get what? Time equals distance over velocity. There we go. We've solved it. We can end the lecture. At 20 years old. Well, then I had to think about, what does that formula mean? Time. Time is distance divided by a speed. So I thought about that. Well, the clear thing is I know what a distance is, correct? In space. And I know what velocity is. Well, what does it mean to have a distance divided by velocity? Now, what you could do is just plug in. Well, maybe I'll get clear if I just plug in for velocity. And what is velocity? Distance over time. Now I got it. Finally, time equals distance over time. Uh-oh. Yeah, exactly. What? Am I getting any further?
It's like a bad trip.
Now, part of the thing is I'm going in circles. You can't use, if you're trying to define something, you can't use the thing you're trying to define in the definition. So what do? Well, I just plug in. I plug in this here, and then I'll get out of, and what do I get? Distance over, well, you see, time is distance over velocity. And if you want to know what velocity is, then again, we're going to go distance over velocity forever and ever. Straight into hell.
Dang it.
Straight into hell.
Okay.
There's a problem.
It's impractical.
Why isn't this formula telling me what time is? I thought that's what formula is supposed to do. Because formulas presuppose theory. Remember we talked about this in the philosophy of science? We don't work from facts and evidence and formulas to confirm a theory. We start theory first. The formula only makes sense in the theory. In other words, this here already supposes a theory of space and time. That's why it's circular. If you try to use the formula to tell you what time is, you're in circles. Why? Because it can't tell you what it is. It presupposes a general or grand theory of what it is in which it works. Same thing with gravity, Newton's inverse squared law, or any other kind of formula that you want to pick in. It's embedded within a theory. Got another problem. So even if I can get this, that's my first thing here, I've got a problem here. Suppose we have a red tape that you go through to mark a place in space. So right at that mark in space, you look and it says 55 miles per hour. That is not your actual instantaneous velocity. Did you know that? We don't have a precision there. That's just simply telling you what? Velocity equals 50, if I go 55 miles. So whatever this actual instantaneous rate of speed is, if I keep that up over a distance of 55 miles, I will cover that in 1 hour. I will cover 55 miles in 1 hour. That is what we call an average. An average does not give me an actual precise instantaneous velocity, does it? This mathematics isn't going to work. I need a mathematics that can give me actual instantaneous velocity. Does anybody know what it is? Yes, calculus. We need calculus. Why? Who wants to learn calculus real quick?
Yay.
I'm looking at the website. It's called the Rack Solution. It's over by the hospital.
Oh, cool.
But you can get a card for 2 floats, and they called it You'll Float Too. That's what they
Oh no, straight from it. You'll float too. You'll float too. I picked up that reference though. Oh, look at that. You never thought you were going to sign up for a math course, but here you go.
I didn't.
See what's so great about my philosophy classes? What do you learn? Everything. We learn math, ethics, theology, philosophy of time, philosophy of science, epistemology, everything. Which was what? Philosophy is the science of
Everything.
Yay. Okay, let's look here. So right here, I actually have on the left-hand side algebraically graphed out velocity. Okay, so what I have here is my x is a distance. Okay, delta stands for change. So the difference, right, the change of distance that you're making plotted over the change in time gives me, right, the hypotenuse. Right, I can relate that through the hypotenuse right there, and here you see that. If the red line's the actual speed that you're going, okay, I can't use the hypotenuse or the area on the hypotenuse to actually determine what my actual, that red line. Because the red line is changing, correct? And the hypotenuse isn't fitting that line. So what I do, I come up with calculus. And I use integrals, derivatives on this to what? Well, I can actually decrease this. I can take the limit of the changes of a distance over time into the derivative d of x over dt, where I compute the change of time as it approaches 0. Now I get a tangent. I'm running real fast through the calculus here. In which what? That point marks on any point on the red line. So calculus using derivatives can solve this problem. But I've got another problem. I've got to need a theory of space and time. Who created calculus? The devil. That's who.
I believe by
The
definition.
devil, Babu Boucher. Okay, this I'm going to run through real quick. This just goes back to an ancient problem. In mathematics, it couldn't be solved. I know how to get the area of a square. It's side times side. A squared. And squares are different than circles. Now you know that pi r squared is the area of a circle, right? Problem is pi is not a whole number. And now what if I did this? I put the square in the circle. Then I have this remainder. So it's not quite accurate. This is called the problem of squaring the circle. But what if I add a second square? I get less remainder. How about a third? A fourth, fifth, sixth. My remainder becomes less and less. So the question is, what number of areas of squares before it equals the area of a circle? How many squares do I need to put in? What number? 1,000? Put 1,000 squares, and eventually there is no remainder, and the area of a square equals the area of a circle? 2,000? 3,000? An infinite. If I could take the sum of an infinite amount, it's what we call computing the limit, which is exactly what we get here. Here's a little slide for the area under the curve. Can be approximated by summing the area of number of the rectangles. Slabs drawn within it, you see it's green. The greater the number of the rectangle, the thinner the slab is. The more accurate the approximation is, correct? Put more, smaller, and smaller. So that the green area below is a better approximation than the actual yellow area. All right, integration, integrals, that's another calculus right there, where you might have seen it like this. Here, the function of that parabolic arc is expressed as f of x equals the square root of x, in which the num you compute, right, is 0 to whatever. That's integral. But the first person to actually come up with that was derivatives. And guess what? Who can name the two inventors of calculus? Isaac Newton is one, bam. Okay, who's got the other one? Are you looking it up? Or are you checking?
Leibniz. Is it Leibniz or something?
Yes, Leibniz. Okay, if we turn here, because we all know that we keep a secret copy of Sir Isaac Newton's Mathematical Principia.
Oh, you did. Shut up, Dusseldorf.
What did he say?
Oh,
So do you want to
I read it. That's how I got the answers.
Do you want to know solve? Do you want to know?
Here we go. Right there, the inventor of calculus. Well, we got a problem though.
That's what I figured.
I figured out.
Obviously, if you're Isaac Newton, there's nobody as smart as you. Obviously, it takes the smartest mind in the whole universe to come up with what 2,000 years of mathematics couldn't solve. Squaring the circle. Nobody else can be as smart as me. But there's a guy, an imposter over in Germany named Gottfried Leibniz, and he's claiming to have created the same mathematics at the same time as me. Sounds sus, right? Did I?
Wow.
That's awesome.
Yes. Thank you, Lord. Wouldn't it be sus? You don't like it? Wouldn't it be suspicious? Odd? Would it just be a coincidence? Or, in fact, was Leibniz the thief? Now, if you're Isaac Newton, obviously he's a thief. I mean, what are the odds? What are the odds there's even a mind as brilliant as me? So they have a hearing. The Royal Society of Mathematics in Cambridge has a hearing because obviously they're the ones that are going to figure this out. Would the real inventor of calculus please stand up?
Please stand up. Please stand up.
And they found out that, lo and behold, Isaac Newton was correct. He was the one who invented, and Gottfried Leibniz was the imposter. Or didn't invent it after.
How do you invent something? if it's
Now-
already invented?
That might not sound too strange to you until you find out who the president of the Royal Mathematics Society of Cambridge is. Any guesses?
Isaac Newton.
Isaac Newton. Shocker. Oh, we ruled that I actually discovered it first, and you were the imposter. Well, it's not until after Leibniz's death that they awarded him. Actually, he did create calculus at the same time, completely unconnected. It was a different type of calculus, integral versus derivative. And even mathematicians today say that they even think that the integral is a more beautiful form of that.
How can that be beautiful?
Okay. But we need time's connected to motion. What's the relation to space? You can only move through what? Space. So let's talk about theory of space. You have two options here. Space is either absolute or it's relative. Now, what might make you think that space is relative is because motion seems to be relative. What do I mean by that? How many people have been on a train next to another train, stationary? Here you are, and here I am. And then you start getting the phenomenon that you're moving. Or is it you're stationary and the other train that I'm on's moving? Have anybody had that phenomenon? You're like, whoa, am I moving? So I've got two reference frames, 1 and 2. And I don't know. It's relative. If these are the only two objects, you'd be both moving. Right? Doesn't matter which one's using the power to move, you're both moving. This one's going this way, and this one's right. The space between you is increasing, so you're both moving. So maybe motion's relative. So what do? Well, I want it to be objective. So I'm going to find something outside of my subjective or relative reference frame to look and judge. And that's maybe it's the tree. We've got a third reference frame here. There's a tree over here. And in virtue of this third reference frame, right, you see that I'm actually doing this something outside my reference frame to something objective. And what? I see, well, relative to the tree, in fact, this is moving and I'm staying still. And then that's how you solve it. You might get this phenomenon too if you're in your car and you're looking down at, you're not supposed to be texting the car, but let's say you're texting like this gentleman here in my class, and you feel that you see something on the periphery of your eye, the car moving, and you start to feel that maybe you're sliding backwards and your brakes on or something. Anybody have that? Okay. So what do? You look up and you look to objective objects. Now the big problem is, what if that tree was on a conveyor belt? Oh, the tree's moving now. No. Well, what if the conveyor belt was obviously stationary? No, it's on the back of a turtle and it's walking through. The idea is you've got to find something that's objective. What if everything's just moving? That's the notion of, then everything would be motionally relative. It means space is relative. Now, let me give you an example. It's either one or two things. Either it's absolute or it's relative. Now, what do I mean by that? Well, let me put up this little funny cartoon here. Imagine you were God. Ah, trick! You're all going to the mental hospital. Oh, my students thought they were God. Okay, that's not what I mean. I mean, imagine God he's going to create the universe. He has two options. Do I create a universe in which there's absolute space or relative space? Well, what does that even mean? Absolute would be absolute reference frame. So it would be something like in the beginning, God creates absolute space. And it's like a box. Why? Because there's boundaries between the edges. And that's what determines the space, right? We're in a room right now. There's space. How do we define that? In terms of the walls that are around us. We're in a container. So space is contained in a container. So that you're objectively in the back of the room and I'm objectively in the front of the room. There's a middle of the room, different quadrants. Does that make sense? So that means each object in the physical universe, if they're moving, would not be relative motion. Why? Well, this could be moving around that, and it seems from your reference point, just like it does from our reference point, it seems like the sun's moving around us, right? But if I put myself on the sun, it would be the earth that looks like it's moving. Now, I don't know which one's which unless I got out of that reference frame. And I'd be like, oh, the sun's actually moving around another point. Now, I wouldn't know, or wouldn't be able to actually tell unless I had an objective container in which, relative to what? Not any object, but space itself is being absolute. What's the second option? God says, I don't want to create absolute space. I want to create relative space. Space is not a thing created first like a container that contains a space. But think about this. In the beginning, there was nothing. Empty, void. God creates a planet. Suppose there's no space there, unless you want to say the space between the continents or something like that. Suppose he creates a second planet. Now space exists. Why? Because it's not a thing, it's not a container. Space is simply defined in terms of objects and reference frames. Does everybody follow me? Now, how would I ever know? Now, one of the problems is, how do I know we're not actually, that the sun's not actually moving, that we're moving around the sun? Well, I'd actually have to get outside of the solar system, that reference frame. But then somebody can say, well, what if you get out of the solar system, and in terms of the galaxy, the sun actually is moving? which is now postulated, right? The sun's actually moving, so it looks like it's more of like a whirlpool kind of thing with all the planets going around. All right. But what if a bigger reference what if I got out of that and actually saw, relative to everything else, Earth is stationary? How would I know? I'd have to keep going and going until I can get what? Outside of the universe. Now, obviously, there's a technical problem with that, of like, how are you going to build a rocket ship to do something like that? There's another problem, a theoretical problem. Suppose I'm at the edge of the universe, right here. I'm at the edge. Here I am. I've got my microphone. Well, ladies and gentlemen, class, I'm standing at the edge. I don't know how I found myself at the edge of the universe, but here I am. We're finally going to, here I am, there's me, and I'm signaling back into you. We're finally going to be able to see what is outside the universe and see what actually is the Earth, the center, and is it stationary? Okay, you ready? Here I am, I'm at the edge. I'm stepping out. This is like the fake moon landing thing, right? I'm stepping out. And what's the problem? I just created more universe. The universe is everything that exists. Every time I try to step out, I just make more of it. I can never get outside. It's like trying to get outside of myself. So this is what we're going to turn to on Thursday's lecture. Well, if I can't empirically or physically solve this problem, either via technology or just in theory, you can't get outside of the universe because you keep creating more universe. How the heck is Isaac Newton going to be able to determine? He's going to supposedly give us an argument that actually says you can. Now, do you believe that? Could you? How would you objectively be able to tell if we're living in a universe that's relative space or absolute? Can't do this. That's going to be pretty interesting to see what type of argument that he actually gives to do that. Now, all of this is going to then, as soon as you think, like, that's so cool, I can't believe he does that, then comes another guy and he throws it all away. No, it's relative. You see relativity there. Which is going to lead us to going to some mathematics again. So not only do you have a degree today in calculus, next Thursday we'll be doing non-Euclidean geometry. All right.
I love geometry.
Thank you, everybody in the chat, for tuning in. And till next time.
The